All right, today we're going to journey to the absolute edge of physics, to a place where our understanding of space and time, well, it just completely falls apart. We are talking about the most mysterious, the most powerful, and just the most extreme objects in the entire universe: black holes. So, what makes them so incredibly weird? Let's dive in.
I mean, this is really the ultimate question, isn't it? We're talking about an object with gravity so powerful that once you cross a certain line, there is absolutely, positively no turning back. Not for a planet, not for a giant star, and not even for the fastest thing in the entire universe, light itself.
Okay, so here's the key thing to wrap your head around. A black hole isn't really a hole in the way we think of one. It's a mind-boggling amount of stuff, of matter, squished into an impossibly tiny space. And that's what creates that insane gravity. The boundary, that line you can't cross, is called the event horizon, and you can think of it as the universe's ultimate point of no return.
Now, this brings up a pretty huge problem, right? If black holes are totally black because they trap all light, how on earth do we even know they're out there? How do you possibly find something you literally cannot see? Well, it turns out astronomers have some incredibly clever tricks up their sleeves.
See, instead of looking for the black hole itself, scientists hunt for its ghostly fingerprints on the space around it. They can spot these glowing, superheated rings of gas and dust swirling into it, kind of like water going down a drain. They track stars that seem to be orbiting, well, nothing. And this is amazing. They can actually feel the ripples in space-time itself, these things called gravitational waves that pulse out when two black holes smash into each other.
You know, because black holes are so strange, they've become this huge staple of science fiction. But what's actually real and what's just a cool movie idea? Let's clear up a couple of the biggest misconceptions right now. First things first, black holes are not cosmic vacuum cleaners just roaming around the universe sucking everything up. The truth is, if you're at a safe distance, their gravity is just normal. It behaves exactly like any other star or planet with the same mass. They don't have some special sucking power. You have to get dangerously close before you're in any real trouble. And sorry to be the bearer of bad news, but they are not wormholes. They don't act as shortcuts to another galaxy or secret portals to another dimension. As cool as that would be, a black hole is a one-way trip to a place we just don't understand yet, not some kind of cosmic subway system. All right, now for the really fun part. Let's take a quick tour of the most extreme, record-breaking black holes that astronomers have ever found. Seriously, prepare to have your mind blown. So let's start with the undisputed heavyweight champion of the known universe. The most massive black hole we've ever seen is an absolute monster known as TON 618.
How massive are we talking? Well, TON 618 has the mass of 66 billion of our suns. Just try to picture that. It's a number so huge our brains can't really even process it.
Okay, so what about the other end of the scale? What's the little guy? What's the lightest black hole we've ever managed to find?
While little is relative, because even the smallest one we know of is still a giant, weighing in at about 3.8 times the mass of our own sun. That just goes to show you, to even become a black hole in the first place, you have to start with an incredible amount of mass. Now, black holes don't just sit there. A lot of them spin, and some of them spin unbelievably fast. The current record holder is a black hole called GRS 1915 plus 105. Get this. It spins more than 1,000 times every single second. Imagine an object with the mass of multiple suns spinning faster than a kitchen blender. The physics going on there are just staggering.
So, what would actually happen if you got too close? Well, the pull of gravity on your feet would be so much stronger than the pull on your head that you'd be stretched out into a long, thin strand of atoms. And the best part? The actual, real scientific term for this gruesome process is, I kid you not, spaghettification. So far, we've been talking about black holes that are way, way out there. But what about right here at home? Well, it turns out most big galaxies, including our own Milky Way, have a supermassive black hole sitting right at their center. Everybody meet Sagittarius A star. That's the supermassive black hole at the heart of our galaxy. It's got the mass of 4 million suns, and it's basically the anchor that our entire galaxy revolves around. But don't worry, having this quiet monster in our downtown is actually a perfectly normal and stable feature for a galaxy like ours.
And that brings us to our final and maybe the most mind-bending thought of all. Let's say, right now, our sun was magically replaced by a black hole with the exact same mass. What would happen to Earth? The answer is almost nothing. I mean, yeah, it would get very cold and very dark, obviously, but Earth and all the other planets would just keep orbiting it, exactly like they do now. And that really brings it all home. Black holes aren't magical space monsters. They're just gravity, taken to its absolute most unbelievable extreme.